Okay, so here's the donation box we were working on, and we said way back when, a couple of days ago, when we started working on this, that when you had a variable like charity name, there was usually a get charity name and a set charity name, although in this case, no reason to write set charity name. And so you'd almost expect to see a get money total and a set money total. So the question is why didn't we do that, and is that a good idea or a bad idea? There's two reasons why it's called donate. Any suggestions? Well, if I use the word set, what does that imply about what I'm going to do with the value that's already there? It sort of says replace, okay? So set as a word tends to mean I don't care what value was already there, I'm going to specifically change it to this, okay? So much as we would like to use that word, the sense is wrong for what we're intending to do with that value. We're going to update it in some way. Okay? So donate or add to or something along that line gives a better sense. Okay? So that's number one. Set by itself is the wrong word. The other reason is that sometimes you want to break the rule to make the word suit the problem. Okay? So if you have a problem where people are using particular sets of words all of the time, then you should use those words when you write the program, because people will understand those words better than they will understand set and get or whatever it happens to be. So we're also going to choose the words that are appropriate to the problem. Okay? So the bottom line here is no matter how many rules we seem to make, the most important rule of all the lot is how can I be the most clear? And so I'll break any rule that I can to try to make things the most clear and obvious that I can for the code that I'm writing. Okay? So yeah, we'd like to follow the standard get set rule, doesn't work. So now it becomes update, but not just update, but in the sense of donate, add to what's already there, which people sort of understand. Okay, now, second thing about that donate method, what about that money variable? Other than that, we have to correct this code to put it back in. Is that a good choice of word there? It's okay. I mean, it's money coming in, and that's what you're donating. Let me introduce a bug. So it's now subtract money rather than add money. Why does that bug suddenly show up? What's wrong with the word money?
Because it can go both ways.
It can go both ways. So let me just use my friend refactor and change it to, if I can spell it, a slightly different word. And now what happens when you read the code? You know that there's a bug there. Because the instant you look at that line, you go, subtract and more don't go together generally. So there's something wrong. Okay? So notice how subtle that is. Just a really simple word change helps us correct a problem. And remember, we're coming from computer science where people were stuck with 6-letter variable names or even worse, and so they always tried to be really, really terse. Well, the problem with terseness is that it introduces bugs because you're not sure about what that thing means. And so there's an example of just by changing the word, you make people stop and think very carefully about whether or not that line is correct, whether or not they've even tested it. They can look at the code directly and go, oh, no, that's wrong. Okay? So we're going to, again, I keep saying we're going to work really hard on getting those variable names to say exactly what we mean and to be helpful. Okay. So there's donate now fixed up, and we can say this should now be plus equals. Okay, let's move on to a different problem. When we were writing this driver isn't actually being used for any practical purpose. It's not the start of a program that's going to somehow turn into this wonderful donation facility that people are going to use. All that we're doing with this driver is we're just basically kicking the tires of the donation box thing, trying to see whether or not it works appropriately. So it's really testing it, not making good use of it. Okay? So it's sort of roughly, you're going to go out and buy a car, you go out and you kick the tires and you take it for a test drive, and then eventually you're going to use the car for some real purpose. So we're trying to build this donation box thing so that it can be incorporated into somebody else's larger program. Okay? And we said that the problem with this stuff that we were writing is it's sort of kind of all over the place. And we've got this program, this main program, that's just going to keep growing larger with really these little chunks of ideas. Oh, gee, I wonder if the value is increments by once. Oh, gee, I wonder if it increments again. I wonder if the name is set right. You're asking a bunch of little questions, and this thing is turning into this big monstrosity of a program. Okay? So somebody finally came up with a better idea. They said, well, let's find a better way of testing. Okay? And so we're going to try a better way of accomplishing this same task, hopefully in a more meaningful way. So what you do is you go to donation box, and we're going to make a file new, and there's an option here to say someplace along the line JUnit test case. Okay? And the trick is to make sure that before you do your JUnit test case, you select the file that you're interested in testing, just because it'll pre-fill in some stuff for you. So I selected donation box, and then I went to new JUnit test case, and notice what it filled in for a name. It just added the word test to the file name that we already had. So this thing is going to be donationbox.test.java. Okay? And it's just designed to say, okay, this is now a file whose job it is to test donation box. There's a bunch of things that you can click in here. I'm going to click this setup beastie and get it made for me just because we're going to use it at some point, although not right away. And then click finish. This thing requires another set of pre-written code in a library, and so we'll say yes to that. And notice that it added in a JUnit 4 library as extra gunk. And it's given us this donation box test code pre-written. We'll just ignore the setup feature, and we'll look at this test that it wrote. This test is just something that you're supposed to go change, but all of the tests are going to begin with @test. They're going to have some name, and then they're going to do some stuff. So I'm just going to get rid of that stuff. Okay? So what we'll do is we'll go into the driver, and we'll steal our initial code. The very first thing that we did in our driver was we made a new donation box. So I'm just going to take that concept of I want to do something with a new donation box. Okay, so there our donation box has been made. What can you say should be initially right about that box when you make it? If you were to get one of these things, how would you know that it was suitable for use?
Put some money in and then take it out.
What's the first thing you want to know? If you say to somebody, I always think of this as when you're testing something, It's like if any of you have ever had a 12-year-old brother, you know that when you ask them to do something, they're going to mess with you. It doesn't matter what you do, right? Okay, so if you say, oh, go fetch me a donation box with, from the storage closet because I'm going to go out onto the street, right, and I want it to say SPCA on the front, they're going to come back with something that doesn't have anything on the front, just to mess with you. They're going to give you the wrong thing. So the question is what makes this donation box exactly what we expected to get? The name should be SPCA. So if we were to go ask, if we were to talk to the Bay Center box that comes back and ask it a question, there's get charity name, and I'm going to put that into a string. What would you expect that name to be? So that thing should be SPCA, so name dot equals SPCA. Now, be careful not to use double equals here. It means something else. String is a smart thing, and so dot equals is a character by character comparison, which is what we actually want in this case. So the name should be equal to SPCA, and the way that you test for that is you say assert true that. Okay, that's all there is to it. And anytime you see assert true, I'm going to read it as I think that, because that's really what it means. I think that the name should be SPCA. Okay, that's all it means. Okay, so there's our test. This is really not just generic test. This is testing to see, is the box set up right? So I'm going to call this box set up correctly. Okay? So you try to give the test a name that reflects the idea that you're trying to test. Okay? Once you've got the thing set up, you hit the run button on the test, and you get this lovely green box that says it worked. Just for fun, let's break it. If we go back into our donation box class, somebody might have done something like this. We'll do another one. In general, what does that say?
Every charity is going to be Salvation Army.
Every charity box that we make, regardless of what anybody tells us, is going to come stamped out saying Salvation Army on the front. Okay? So, obviously wrong. Okay? Because we're ignoring what's being said to us. So now if we go back and we run the unit test, I'm going to select the unit test, and I'm going to say run. Then it says it's incorrect. Okay? If you want to find out what's wrong with it, because I've put this thing into a separate variable now, the easiest thing to do is just go back and put a breakpoint on this thing and run with the debugger and do a step over to get the value put into the variable. And now when we go look, you can see that the name that's come back is Salvation Army, and that's definitely not SPCA. Okay, kill that thing off. We don't need it with the debugger anymore. So you can debug unit tests just like you can regular main programs. We'll go back into the Java view of things. I guess we should correct our bug. So in donation box, I'm going to change it back to what it said before. Okay. Anything else that should be true when you first make that donation box?
Your money should be zero.
Money should be zero. Well, the test would be, same sort of thing, talk to Bay Center dot get money total, and it should be exactly 0, and you can encase that in what's really the equivalent of an if statement. I think that that thing should be 0. Now that's the shortcut, and I've said the problem with that shortcut is that you won't be able to see the result easily. So I'm going to play this game of taking that value out, and I'm going to put it up here, and I'm going to say int money equals, there's what I expect to see, and I think money should be equal to 0. It's just easier for the debugger more than anything else. I'll go retrieve it and then I'll look at it. Okay? Is it going to work? Oh, look. It worked just fine. It's not going to say anything there yet. Okay? So now we know that the box is set up correctly. How would it ever be anything but 0?
Submit and empty it.
It seems like that's a stupid test, because what are the chances really that it would be anything but 0?
Someone can make a mistake.
Easiest mistake, fat-fingered Pfeiffer gets another extra digit in there. In a hurry, got to get this thing done. Type some number or 01 or whatever the combination happens to be, something other than 0. You go, yeah, it works. Off we go. You run the thing, and all of a sudden, when you run the test, it says, no, it's wrong. Notice you get the red bar, nasty red bar says didn't work. Okay, so there's one more test. Let me just go back and fix that thing up. There's the bug. Again, you could go look at the value and see that it's wrong, and then you can go dig in the class and go, oh, well, that's just not right. Okay. So now we know that the donation box is set up correctly. That's pretty much done. It's got its initial values. How about another completely different test? What would be the next thing that you would want to see to know whether or not the box worked correctly?
Then you can put money in.
Now you can put money in. Okay. So every time you write a test, be careful to say at test. Otherwise, it'll just ignore it. And it's always public void, and then think of something that accurately describes it.
We'll accept money.
It's not that it'll, well, okay, sure. We can always change it later.
Feels like discard.
Okay, so there's that thing. So we'll borrow we're still going to start out with a donation box. Now, since we know from the previous test that it's set up correctly already, that test will typically run first, so you don't have to worry about whether or not it's set up. We can just proceed under the assumption that it actually works. So what would you do to see whether or not it works correctly?
Give it some money.
Give it some money? Okay, sure.
And run a get
Bay Center dot will donate some amount of money. Notice, by the way, it told me more money because of the variable name. And then what?
And then we have to get money to see that the two values match.
Get some money, so we'll do Bay Center dot get money total. Oh, look, we've sort of got that code here, don't we? Let's just steal that. So one of the other joys of unit tests, by the way, is once you start writing one of them, it's amazing how much of this stuff you can just grab and morph a little bit. So money total should now be 100. Okay? So now we'll run that test. And now if you crack open the plus sign, here's the reason for trying to use good names, is because it's going to just show you the names of all of the tests that were successful, along with the idea that you were trying to test. Okay? So those names become important because they're just a quick look for somebody to go, okay, all I need to see is the name to know whether or not it worked.
So if you're testing multiple things like you did in the first test, the box set up correctly, if one of those fails, does it tell you which one failed, or do you have to go through them?
It will tell you which one fails.
Okay.
It'll tell you, it will actually, well, let's just do that. This one here has got multiple ideas. Let's just change money so that it's back to something silly. We'll go and we'll change this thing to 10. Now that we've got multiple tests, we'll run the thing again just directly, and oops, did I run the right thing? Run that thing. There we go. Notice both tests fail. That's not unusual. It wasn't set up correctly initially. But if you click on the test, on the set up test correctly, just double click on it, it takes you to the assert statement that failed. Okay, so you double click on it, put the breakpoint on it, go have a look and see what the values are, and off you go. Okay, so we'll go back and fix that one to what it was. And let's talk about this unit test here. I'm just trying to think of where I want to go next with this thing. Should we add more money in this test?
Different denomination?
Yeah, there's a couple of things we could do. The question is, should I make this bigger or should I start another test?
Start another test, just in case.
This is sort of this creeping featureism thing, right? I mean, I could conceivably go here and say, well, I'll just add some more money and see whether or not it continues to go up. Okay? But the problem with that is what happens with tests then is that the whole thing you were trying to prevent in main was from doing this. I'm going to do this and this and this and this because it's too hard to follow. And the same thing happens with unit tests. If you start doing complicated unit tests, it becomes I'm doing this and this and this and this. And they're actually two separate ideas. The first idea is, can I get it to take any amount of money and go up? And then the second idea is, will it continue to increase and add to the total rather than replacing? Okay? So notice that those are two different ideas. Okay? So I would actually do another test. And here's the joy again of saying, well, I know that it will accept some initial money. And so I'm going to change this first test to say will accept initial money, and I'm going to change this one to say will continue to, oops, add money. Hopefully that's fairly clear. So now we can start it as 100, and now what we'll do is we'll just repeat that same stuff again. How much money do you want to add this time? Yeah, something other than 100. I'm going to add 50 just because I can add better than 50. And now money should be how much?
150.
Should be 150. Okay. Run the test again. And crack it open, and you can see all three of the tests ran, and yeah, it's 150, so it looks like it accepts at least a different value. Okay, good so far? Let's just do one more of these, just to be sure. 3 always seems to be a good number. And now it should be how much?
175.
175. Okay, save it, run it, all of the tests pass. Okay, and so now it becomes a matter of green bar versus red bar. If you get a red bar, it's broken. Get a green bar, you can continue on. And notice what happens every time we write a test. You now firmly start to believe that this thing actually works. And the other advantage is that if for some reason some student runs me over tomorrow, the next person who looks at this code will be able to know exactly what I did and didn't test. If a bug gets reported, you can go and you can write one of these tests. You can see whether or not you can actually make it fail. And when it fails, you go back and write the code to correct it. And so every test strengthens your belief that this thing actually works the way it's supposed to. Okay, how about this 100, 150, 175? It's not bad, because notice one of the things that happens is that human beings are really, really good at seeing patterns. And so if you can show something like this that's a pattern, you can give this to your mom and your mom will understand it. You can go, hey, look, Mom, I put in 100, I asked, and it should be 100. I added another 50, I asked, it should be 150. I can explain that test to my mom, and she can look at the pattern, and she can go, yeah, I can see that pattern, it must be right. And not only that, but if you do something silly, it's easy from the pattern to see what the silliness was. Okay? Human beings are very, very good at spotting this sort of stuff. Now I'm going to get lazy. I was never very good at math. And you people are making me work, okay? Because where did this 150 come from?
100 plus 50.
Where did the 175 come from?
150 plus 25.
So 100 plus 50 plus 25.
100 plus 50 plus 25. And now look what happens to the test. It's even easier to explain to Mom, because there's no calculator necessary. I don't have to wonder where did the numbers come from. I can look and I can say, oh, it goes 150, 25 down the page. It goes 150, 25 across the page. I guess that must be correct. Really easy to spot the pattern. Okay? So almost always we like to do really simple tests, and we like to get patterns involved in tests because that just makes it easy for people to spot things. Okay? And so there's a beautiful little test, run the thing, and it works just fine. Okay? Anything else we should test? We'll go back and look in the donation box class. Scroll down. Okay, clear. So let's do clear. So, donation box test. We'll add in a test for here's a test to see whether or not clear works. Same thing, put in some amount of money, really doesn't matter. I can steal all of the stuff I've got already. There's the money. We'll click the fit and we'll do base center dot clear. And what do you expect to see?
0.
So if we went and looked at money, oops. If we went and looked at money again, steal that little bit. Go get it. The value should be 0. Okay, run it. Test works. Is that a good test? Not quite. Testing is all about paranoia. And testing is all about saying exactly what you mean. What's wrong with that test?
You didn't know if the money went in there in the first place?
No, you know from the previous test that the money is there. Okie dokie, let me just go back into donation box and
We didn't test the name.
isn't that what clear means? Doesn't clear mean
Everything?
everything? Didn't tell me otherwise. Seems like that's what it should do.
So clear money?
Well, clear is sort of fine. I mean, I don't mind it. But really what we meant is that not only should the money be set to 0, but what we actually meant is that if we go back and do this afterwards, let's put it here after the clear, 2 things should be true. It should still say SPCA, and money should now be 0. Okay, remember what I said, 12-year-old brother messing with you? I said clear, well, I'll just purposely misunderstand you and do the wrong thing. So people who are testers are in the habit of saying, I'm going to be really careful about things because that would be a perfectly reasonable thing to do. Notice the other advantage of the test is that the test actually defines exactly what behaviors you expect. Okay? And in real life, it works the other way around. Somebody writes the test first, and then they turn around and say, make the program work so that it passes all of the tests. Because the tests define exactly what behaviors you're expecting. Okay? And if you get the tests right, the joy is I can write unit tests, I can go and I can farm out the work to all 30 of you people, and I can go, first person that brings me back code that passes the tests, I'll give you $100. I'll buy your code. So now you can have competing people working on the same product, and when it meets your approval by passing all the tests, that's the code you buy. That's an engineering principle, which is exactly what engineers have done forever. When you build a jet engine, the US government wants one for a fighter plane. They go and they define this huge document that says, when I put this engine into a test jig, it should be able to go 6,000 RPM for 10 hours. It should use not more than this amount of fuel. It should generate no more heat than da-da-da-da-da. They come up with a complete list of things. It should be able to rev up to speed in some amount of time, right? And then they go, once they've got this test document ready, they send that out to all of the different people who might build a jet engine, and they say, build me one that works like this. So no jet engine exists, okay? So when you start doing it, we actually sort of work in the wrong order, right? We're working in reverse just to get our heads wrapped around it. You actually build the thing and write the tests, okay? What happened to the driver? Do we need it anymore? No, not really. So we can, if you're good at it, you can still make the tests and then write the code and not bother with the driver. I'm going to suggest to you that the advantage of a driver is that it allows you to basically kick the tires in a sort of relaxed way and try things out, just to see, just to, use it as a sort of a scratch pad for ideas. And so I still think it's a good idea to leave that main program there so that you can toy with it as you go, and then write tests based on what you get from main, and then test it to see whether or not it works. Okay? By the way, if we had the space, this is how I would do exams. Because all I have to do for an exam is give you a word problem, give you 50 tests that you have to pass, and say, hey, it's 2 marks per test. Get them all to work, you get 100% on the exam. And I've actually done this when I've had a really small class and I could stand behind them and make sure they weren't cheating. And it's just like going to the casino, because you get people, it starts out and it's all red bars, right? And people go, oh, tap, 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 tap. And they pull a big lever, right, hit the button, and they go, oh, green bar, come on, green bar, green bar. Oh, no, still red bars. Tap, 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 tap. Whoomp. Green bar, down. It's beautiful. I mean, it really does work as a code writing mechanism. Okay, so there's unit tests, and that's all there is to it. You just come up with simple little tests for things. Each test is individual. They have good names associated with them. Test one little thing at a time as you go. Make sure you use patterns for your testing wherever possible. Don't make assumptions about what you think things should be, right? Write the test that says this is really what I expect them to be. Okay? Beautiful little tool. This testing idea is only about 10 or 15 years old, doing it this way and using this unit test stuff. But it's become a big thing for companies to do because it's very expensive to send out a product and not have it work properly. And if you keep sending things out that don't work, after a while people go, they're an idiot, we're not going to buy their product. And not only that, but if you send something that doesn't work, your phone starts to ring. And that means that you're spending all your time answering the phone and trying to basically do firefighting rather than moving on and writing new code. Okay? So this is a very good process. Okay, last call for questions about this particular example. Let's do it one more time. Got a few minutes, let's start another one. Get rid of this, go back to the Java view of things. How about a new problem? I want to make a class that represents a bicycle. Nice physical object. So I'm going to go and make a new Java project. And I'm going to start out and I'm going to make a new class. Call it bicycle, no main in this one. There's my bicycle class. What information do you think we should keep about bikes?
Spokes.
If you go out and buy one, or a friend comes with their brand new shiny bicycle, what's the first question you ask?
How many speeds does it have?
Probably how many speeds does it have? And particularly if you come from an era where there was 3 speeds and then 5 speeds and then 10 speeds and then whatever we're at now, 21 speeds. Okay? So one of the things that's probably sort of interesting is this is gears. We'll worry about that word in a minute. So it's got a certain number of gears. Anything else to care about?
What flaps?
I want things that do stuff, right?
Rat trap model.
So gear does stuff. Oh, I'll just go with gears. What the heck?
Well, lights,
I'm feeling lazy. Let's go and make a new
have an alternator.
class here. Now, we could make a unit test, but this is another one of those of, I don't know much about the bike yet. I think I just want to see if I can help the main program give me some idea of what this bicycle thing is all about. So I'm going to make a bike driver and make sure I have a main in it. And get rid of that crud. Okay, so you order a bike from the factory. There's this idea of there's a new something, and the thing I'm going to do is a new bicycle. What sort of information are you going to ask when you order one?
What features does it have?
What material it's made of?
What did we just put there?
How many gears?
How many gears? So when you go and you order one from the factory, one of the important things you're going to do is you're going to specify how many gears you want on the bike. Okay? So there's this idea that new is always associated with, if I were going to go make one, if it were a brand new, fresh thing, what would I have to supply in order to get the thing that I wanted? And that has to go into a variable, someplace to remember it when the factory gives it back to you. So we'll call it my bike. And what kind of thing is that variable?
It's a bicycle.
It's only going to refer to bicycles, so we'll stick the bicycle word on the front. So there's my bike as a 21 speed. Why is it complaining?
We haven't given bicycle parameters.
So I haven't specified this constructor thing, and it's saying, gee, you're using an integer there when you're making a bike. You need to have a constructor that does the same thing. So now you know you need to write public bicycle, and you need to say int in gears. Now what?
You have to assign it.
You have to remember it, right? I mean, this is like with, you're supplying this information to the factory. When the factory actually wants to make one of these things, it says gears equals in gears to remember it. Okay. Well, so back to the driver for a second. So I've made my bicycle. There's the bike. You're wheeling it down the street. What's the first question somebody's going to ask you?
How many gears you got?
How many gears you got? So there's a question. Talk to my bike and say get gears and int gears equals get gears. Okay? So that reinforces the idea that basically anytime you have a variable up there, it's not a surprise that you're going to have a getter that says public int get gears that returns the number of gears on the bike. Okay? What about a set gears?
Well, you can't really change it because it's kind of set in stone.
Yeah, it's sort of kind of set in stone, I mean, people do replace gears on their bikes, but it's probably a specialist thing. Most people don't. So whatever it comes with is what you get probably forevermore. So you're never going to write a set gears in this case, so we just won't give people the capability to do it. You buy it, that's what it is, tough luck. Okay. Now what are you going to want to do with your bike? Hey, it's got 21 gears. You could print it out, you can look at it in the debugger. I'm just trying to get the form of question and answer going there.
Well, the features does it have?
What's the very first thing that you do to use that bike?
Take for a spin.
Take it for a spin means doing what with it specifically?
Riding it?
Sit on it, pedaling.
Pedaling.
Braking,
So some idea of some action, if you do my bike dot pedal, we'll go into the bicycle class and we'll write public void pedal. This changes what the bike is doing. What happens when you pedal?
We go forward.
Come on, physicists.
You convert the rotation of the pedals into forward.
Childlike physicist, what happens when you pedal a bike? It goes forward because
Acceleration.
the speed goes up. So some notion that when you pedal the bike, it goes faster. Now, this is go faster by 1. In truth, the bike probably goes faster depending, more or less faster depending on what gear you're in, and we can always go fix that later,
And how fast you pedal.
okay? But for now, when you pedal, the speed should go up by something, okay? Oh, well, if the speed goes up, the problem is I need a variable that's going to keep track of speed, and I'm going to call it current speed. And it's not unusual to see people use that current word to give this sense of it's somehow changing on a regular basis. So I'm just going to change that to current speed goes up. Well, if you've got a variable called current speed, you're going to need a public int get current speed. So that somebody can ask the question, hey, how fast are you going?
Wouldn't really know.
Okay? Okay? So notice the sense of when I developed this. I didn't worry about writing a whole huge bike class. I just started with one small thing and said, let's build on it. The advantage of that is that even if this assignment was a very big assignment, you always have something to show. It might not be a perfectly working bicycle, but gee, guess what? You can order it, you can pedal it, the speed starts to go up, things happen with it, and tomorrow what we'll do is we'll build on this to not only get a more complete bicycle, but also start writing some more unit tests to check and see whether or not the code we're writing works properly. See you tomorrow.